right? Correct? And I started differentiation, right? Right, and I went through a few differentiation. We did product rule, quotient rule, and so on, right? Yeah. Did I integrate tricks? Sorry, differentiate tricks. No. Sorry. Which one? Not going to tricks. I'm going to tricks, but I went through the rules, right? So I went to the chain rule, the product, the quotient rule, right? Okay, good. So let's start back with integral of differential of tricks, and then we'll move into second differential, and then some application. All right. So let's take a look at differential of tricks. Right, so some of the rules that we need to remember: if we had y is equal to sine x, right, then the differential of sine x is simply cos x. What's the differential of cos x? The differential of cos x is minus sine x. If I ask for the differential of tan x, how you work out that? How you work it out? Remember, tan is sine and cos, and then you use quotient rule, right? What's the differential of tan x again? You'll end up with sec squared x. Just in case I have, let's just say I have to differentiate cosec x. What you will do? One on sine, and I use quotient rule if you want, right? Right, you don't want to the quotient rule and then simplify it out. Try it now. Try and differentiate this from here. This is 1 on sine x. What's the differential of that? Yeah. Right, so one of the ways that we can differentiate this is we can write it like this: u is 1, v is sine x. Right, so du dx is what? 0, and dv dx is, what's the differential of sine x? The differential of sine x is cos x, right? So therefore, dy dx, if we use quotient rule, I'll write it here again. V du dx minus u dv dx all over 3 squared. We will end up with dy dx being equal to v is sine x, du dx is 0, minus u is what? U is 1 cos x. Right, dv cos x all over v squared, which is sine x squared. This is 0, so you'll be left with cos x over sine squared x, right? Which is the same as what? Watch this here. Which is the same as, I can break this up, right? I can break it up cos x sine x by 1 on sine x, correct? So I'll break this up like this. Yeah. So this is what? Cot, and this is cosine. Okay. So the differential of cos x is cot cosine. Right? But okay with that? I don't want you to try this because you'll get it wrong. will work out, right? This wouldn't give you this. So that's the way, so it wouldn't be minus. If I mind, oh yeah, thanks, later. Thanks, Emily. Thanks, yeah, minus. Right, so that's what your differential will look like, right? And of course, why am I not seeing this now? Oh, I'm going the wrong way. Right. Nice. That's a little idea how to differentiate those, right? Now, if you change this up, now to what you will actually see, right? Suppose we had to differentiate sine ax plus b. What's the long way to do this? Which rule? What's the long way to differentiate things like this? Anybody remember? What's the long way? Remember that chain rule? You can use chain rule to work out these, right? So u is equal to ax plus b. So du dx is equal to a. Y is equal to sine u. So what's the differential of y with respect to u? What's the differential of this? Cos u. That's it. dy dx will be equal to dy du multiplied by du dx. dy du, that's cos u. And du dx, that's a. So the answer is a cos, but you can't write back u. So you write back ax plus b. That's a long way using chain rule. That's okay? That's a long way using chain rule. Right? That's a long way using chain rule. Right? What's the short way? Right? The differential of sine and cos, the differential of ax plus b is a, and then I write back ax plus b. Right? So let's do my quick favor. Write down the differential of cos ax plus b and the differential of tan. Right? Do the short way, right? Right, remember, for the crash course, you all can submit the form division via WhatsApp, right? And then you can pay later on, right? I want to make sure they have the safe side, not much. Right, differentiate those too quick. Start here, please. Finish. Yeah, so the differential of cos ax plus b, the differential of ax plus b is a, differential of cos minus sine, and then you write back ax plus b. Same thing here, differential of ax plus b, a, differential of tan sec squared, and then you write back ax plus b. Okay, so that's basically how you integrate tricks, right? Any other version, well, you'll have to use one of the rules to simplify it, right? Right, so that's basically how you differentiate. When you add this and what we did last week, that's how you differentiate, right? You want to take a look at a few applications of differentiation. Right, oh, by the way, I just find d2y dx squared again. Differentiate a second time, right? So you're basically differentiating dy dx. So you're differentiating dy dx again with respect to x. Right, that's d2y dx squared. Copy that now. Let's try this fast. All right, so I was remember that, right? Right, some of the applications of differentiation. The application of differentiation basically similar to what you would have done in Form 5, right? So one of the first applications is when you have dy dx, that'll be equal to what you call a gradient function. Remember that? When you find dy dx, you're given you a function that can help you find gradient, right? And when you substitute x is equal to some value a, what you will end up with is the gradient. And let's write this properly. When you take dy dx and you substitute x is equal to a, you will end up with the gradient of what? But remember, tangent. You'll get a gradient of tangent. Okay? And for those who kind of forget about gradient of the normal, gradient of the normal is what? Gradient of the normal is equal to -1 over the gradient of tangent. Right? I'm not going to spend too much time on this version, right? I'm going to spend more time on something new called points of inflection. So that's your first application, right? Your first application is to be able to find the gradient function. Right? That's the first application there. The second application that we're going to focus on is to obtain maximum and minimum values. Right? So you may remember this. You may remember that when dy dx is equal to 0, what has happened? A stationary point occurs, right? So when dy dx is 0, a stationary point occurs. Right? That's when dy dx is 0. And when d2y dx squared is more than 0, is a what? Right? Point is a minimum, right? And when d2y dx squared is less than 0, the point is a maximum. All right? So that's the Form 5 stuff. Okay? That's the Form 5 stuff there, right? I want to focus on something a little bit new. Are you ready? Ready? Right. So we all remember this, right? Right. Now there is something that we're going to look at that will bring us into a new point, right? A point of inflection. Right? We're going to take a look at a point of inflection. But first thing, let's redefine how we determine a minimum point and a maximum point using the first derivative test. Right? Using the first derivative test, let's see how we identify a minimum point. We know at this point here, we know that dy dx is 0 here. That's okay? We know at this point dy dx is 0, that's a stationary point. Right? This function here, when I watch it, is it increasing or decreasing? Decreasing, right? So if you were to find dy dx at this point here, anyway, along this point here, you'll recognize that your dy dx is less than 0 because it decreases. Here, dy dx begins to increase. So basically, you could see that your gradients decrease in here, and then the gradients begin to increase here. So here, your dy dx is going to be more than 0. So whenever your first derivative going from less than to more than, what you have is a what you have here is a minimum. That's okay? So if you have a stationary value and you choose a value, like let's make up something, right? Let's say x is 2 here. If you choose x is 1 and x is 3, and you plug 1 into dy dx and you get something less than 0, then you plug 3 into dy dx more than 0 and you get a sign change, less than to more than, you have a minimum point. Right? If you do the same thing underneath here, and you went from dy dx being more than to dy dx being less than, then what you have here is a maximum point. That's okay? That's your first derivative test. So once you have a sign change in a dy dx, you have a maximum in. That's okay? But what's this new stationary point here? The function is what here? Increasing. So the function is increasing here. What about here? It's still increasing, right? So the function here is still increasing. So if we choose our two values around the point of inflection, and we recognize that the first derivative not changing sign, what we have is a point of inflection. That's okay? So if there's a change in sign, maximum. If there is no change in sign, point of inflection. That's okay? Copy this out. Copy this out. It could also be the other way around, right? dy dx is less than 0. Right? You also have a point of inflection. Ready? Right, so to determine if a stationary point, we just taking a small note, right? To determine if a stationary point, is inflection, to determine if a stationary point is inflection, right? We do the following. We do the following. We do the following. Solve dy dx equal to 0. Solve dy dx equal to 0. Solve dy dx equal to 0. And step 2. Step 2. Apply the first derivative test. Apply the first derivative test. To determine the type of stationary point. Apply the first derivative test to determine the type of stationary point. Note that if the second differential is equal to 0, note that if the second differential is equal to 0, then for that x value, we need to determine, note that if the second differential is equal to 0, note that if the second differential is equal to 0, we need to determine if that point is a point of inflection. All right. So let's try a small example on how to determine if it's a point of inflection or not, right? F of x is equal to minus x to the fourth minus x to the fourth minus 2x cubed plus 2. Right? Let's determine the nature of each stationary point. Let's determine the nature of each stationary point. Right, so first thing first, here we're doing find the first differential. Find the first differential, and then let it equal to 0 to obtain stationary values. Try that, please. Find the first differential, make it equal to 0, and tell me what you get for the x values. All right, and then we're going to determine which is max, min, or inflection. Yeah. Right. Minus p will get p. Put out the minus plus p. These two things are the same. How we done that? Right here, we sign here and everything is here now you have to fill so we can which you can write it out long 6. Right, long 6. 12 is 6 by 2. Like and then so so you can just pull out what they would have in common. I will show you how to look at the number. They would have what in common. Number 6. They would have in common with years. Yeah, straight up one side, for the next side. They would have to straight in common. So you can have those straight. But it would have in common with the but those would be then right what you get. This one's a program. Yeah, look at the steps. Right, so your first differential is what? Minus 4x cubed minus 6x squared plus 0. Well, that's 0, right? And then you have to solve minus 4x cubed minus 6x squared is 0. What you got? Or we can factor out here. Negative 2x squared. And you will get 2x minus 3. Correct? So when this is 0, I'll get minus 2x squared is 0. I'll get x is 0. So what's y now? Y over 2. So the first point here is 0, 2. And then here, x is equal to 3 and 2. Okay, not 2x minus 3 is 0, so x is 3 and 2. Tell me what y please. What do you get for y? Check us tell me what you get for y. So won't it be minus 3? Yes. When you carry across the 3, you'll get positive 3 and 2. Yeah. Positive 3 and 2. Yeah, that's what I have there. Oh, all right. Here me, I do wrong. Here is minus. When I factor out the minus 2, yeah. But I get plus. So this is minus. Thanks, Karina. Yeah, thanks. Right, so it's a plus here. Thanks. Nice. So what you get for y now, please plug in this here. So what you get for y? Chances. Read this out. Take a time and read this out. That's supposed to be there. So step 1, write what ABC. What ABC? B, and C. Right, now step 2. You just step by some. Try to do it right for these steps. It might be a step. It might have a figure out how these steps. Don't give it right for these steps. Yeah, how much you got there? How much? 59 on 16. All right, good. Right? That's just the point, right? So the point is minus 3 on 2, 59 on 6. Now, we're going to try to use the first derivative test, right? Nice, Shabani. We're going to try to use the first derivative test. Right? So we're going to try that first derivative test now to determine if this is a max or a min. Right? Same thing here, if it's max, min, or inflection, right? That's okay. So first thing first, let us see where the points are, right? On our number line. This is -2, this is -1, 0, 1, 2. So on the number line, our points of inflection, our stationary point, one is here, and the one is -3 and 2. That's okay? The reason we're doing that is if you choose the wrong points, you're going to get it wrong, right? So for example, remember I told you to choose 2 points around this stationary value here. So this value here, Adam, is what? -3 and 2, right? This value here is, of course, x is 0. So when you're choosing the values around this to determine if it's time change, you don't want to choose a value quite here, right? I'll show you the problem that could possibly happen, right? So let's start with the easy one. Let's start with when x is 0. We're going to use first derivative test, right? When x is 0, we know what it is, right? So let's choose 2 values around x is 0. Let's choose x is equal to -1 and find dy dx. dy dx is what? dy dx is -4 by -1 cubed -6 by -1 squared. How much is that? I just need the sign. I don't need the value. This will give you a negative, positive. What do you get? -4. You'll get 4 minus 2, so you'll get less than 0. Check and see. Less than 0. All right. Very good. So this is -1 by -4. That's positive 4. -1 squared is 1. So you're going to get -2. Are you okay with that? So that's what? Less than 0, right? So that is less than 0. Are you okay with that? Let's choose our next value now. Let's choose x is 1. We're choosing values around 0, right? So let us choose x is 1 now. So what we'll get? We'll get dy dx is equal to -4 by 1 cubed -6 by -6 by 1 squared. So this is so you have negative value. What does that mean? Both of them less than 0, right? So it appears that it looks something like this. dy dx here is less than 0. dy dx here is less than 0. So it appears that 0, 2 is an inflection point. Are you okay with that? As well, follow what on there. We'll study that now. Next year again. All right? You lose it for you? 3. Right? So 0, 2 is a point of inflection, right? That's okay? Because the signs stay the same. Are you okay online there? But let's make sure I'm really going to read comments. Sharia, Brittany, are you okay there? So because dy dx stay the same, right? Because dy dx stay the same, we end up with a point of inflection. I want to show you something, right? Let's just choose when x is -3 on 2. Let's choose 2 values around it. Let's choose -1 and let's choose -1. We already have that. dy dx is less than 0. And then let's choose -2. What will that be? -2 is what? -4 by -2 cubed -6 by -2 squared. How much is it? Greater than 0, yes, that's all I want. That's all I want. Greater than 0, right? Right, nice. So you went from where? -2. So you went from -2 where it's more than 0 to less than 0. So dy dx is -2, it was more than 0. Here dy dx is less than 0. So therefore, -3,2 and 59 on 16 is maximum. Are you okay with that? Saskia, you okay with this? Right, but here's the problem. Watch this here. Right, Ver? Watch this here. Suppose when you had 0, right? You chose 1 on the right side, and on the left side, you chose -2. What would have happened? You would have gotten them more than and less than, right? Dy dx when x is 1 is a less than value, less than 0. And if you choose this value, you would have gotten more than. So you would have assumed that this point is a maximum. That's okay, but it's not. So you have to be careful when you're picking your values that you know where your stationary values are. There is a stationary value here. So for this value, you cannot choose beyond that stationary value. You could choose any value here, but you can't choose a value beyond that stationary value, right? Because maybe somewhere along, because it may have some sort of concavity, right? That's okay. So you have to be careful when you're choosing your value. Same thing here. Same thing here, right? Instead of choosing, well, no, it wouldn't work in this case, right? Because if you choose 1, you would have still gotten less than 0. It would have still worked out for you. But here, if you chose -2, which is beyond the next stationary point, these 2 points would have given you something that is totally different. The point of inflection. Okay with that? So it's important that you label on a number line your stationary values, and then choose the values that you want to do the first derivative test. Right? Again, if there is no change, inflection. If there's a change, it's maximum. That's okay? So we don't even need second differential. We can do everything with the first derivative test. All right? If you want, you can do the second differential here and check it and see what you do after. Right? Everything can be done using the first derivative test. Any questions online there? Chelsea, are you okay there? Ethan boy is still logging here. As a Ethan in your own class. Right? Chen, you okay there? Koi? Ready? Copy down. Let's go again. You okay with this? Ethan. Which Ethan is this? But is the wrong Ethan? Oh, sorry, Ethan. I mixed up with the next form 5 Ethan. I'm mixing up with somebody else. All right, good. All right, let's try one now. Yeah, sure. All right, let's make a little chart. 2018. I'll write it all because it's not working, right? It's not connecting, but I'll show the picture. And dia part page take a line. Checking the office pass on the mic. Right, let's see if we can find the nature of all these stationary points here. Huh? They want two numbers I can multiply with this. Say please around with 2 and 5. I will allow you 10. 2 and 5 times. Say around with the sign of the 10. Right? So 10 by minus 1. 10 plus 1. Now for the next one. X that is 9m by let's see that. Just factorization. Practice of factorization on a solid and function. Right, we do that. It goes online. Go and look at the Google Class. Try something. Yeah, try them on down here. They come and start a little. Yeah. I'll just message your father. Yeah, are you done? Finish? So you should have the first differential already, right? You should have your first differential already, which is 12x cubed minus 6x squared minus 12x plus 6. Please don't try to divide by 6 to make it look easier, right? This is our expression. Only when it equals to 0, you can do that. Right? When it's an equation, you can do it. When it's an expression, you can't. Right? So first prime equals to 0 to obtain stationary values. All right? So first prime is equal to 0 to obtain the stationary value. So you're solving 12x cubed minus 6x squared minus 12x plus 6 is 0. What you got? What do you got here? So the calculator, let's keep it. Oh, x is I'm a small say ladder, right? Minus 1. 1. Oh, a half then 1. When they ask the stationary points, you gotta find the y value, right? Find the corresponding y values. Right? Find the corresponding y values as well. Then let's determine who is max, who is min, and who is turning point. What shall I get? Start out class and then let's see, right? All right. Anyway, but I can work on that y value, right? The y value is not so important for now. Right? Chelsea have 1 minus 7, 23, and 16. Yeah? All right, good. What is again? 1 minus 7. So here's 1. Yes. Minus 7. And 1 here? All right, good. All right, anyway, we're not too interested in that as yet. What we're interested in is here. So we come to the number line. Minus 2, minus 1, 0, 1, 2. Nice. Where are our stationary values? At minus 1, at a half, and at 1. Are you okay with that? So that's where your stationary values are, right? So here's how we can find. We can find dy dx at 3 particular points. Let's choose -2. Here will be 0. Oh, sorry, here's a half, right? Right, so we're working out dy dx. Just to save some time, we do on table, right? When x is -2, when x is 0, when x is a value here. So for -1, we will choose -2 and 0, correct? For a half, we will choose 0 and something here, right? So let's choose 3/4, right? 0.75. That's okay? As well as follow why I'm choosing that, right? So I'm choosing -2, 0 for -1. For a half, I'm choosing 0 and 3/4. For 1, I'll choose 3/4 and 2. Right? And then we'll check the signs. I do another table just to save some space. Right? So plug in -2 in dy dx, tell me what you get. Less than 0 or more than 0. That's all I want. I don't want anything else. When x is -2, in your first differential, tell me what you get. You assume it's less than 0? Less than 0? What's the next one? Right, next one is straightforward, that's more than 0, right? 3/4. Check out 3/4 in dy dx. Huh? Which one? Which one? 3/4 is less than 0? Yeah, somebody else check it now. All right, well, yeah, online said less than 0 as well. And 2 is what? Less. Huh? When x is 2, more than 0? More than 0? All right, good. So let's see. Are you okay with that? Yeah? So I'll plug in -2 in here, Brian. I'll plug in 0 in here. I'll plug in 3/4 in here. I'll plug in 2 in here. And I get values, get these values here. Right? That's all you're interested in. So when x is -1, right? So let us check the first point, -1, -7. Right? So for -1, I chose these two values. Is there a sign change? Is there a sign change? Right? We went from dy dx being less than to dy dx being more than. So it went from less than to more than. Therefore, it's a minimum. That's okay? Keelan? Okay with this, right? So for -1, 7, I choose these 2 points, sign change, minimum. Right? I'm taking a look at the next one now. 1/2, 23 and 16. What you all think? Adam? What do you think for this one? What do you think for this one? For half. Right? It went from where? It went from more than to less than. So it went from dy dx being more than 0 to dy dx being less than 0. Therefore, is a maximum. Are you okay with that? Lastly, let's check out 1 and 1. So dy dx is what? For 1, 3/4 and 2. 3/4 and 2. It went from less. It went from less than 0 to more than 0. Less than to more than is a minimum. So we end up with minimum, maximum, minimum. Okay with that? Any questions there? Online, any questions? Any questions online? So could you work out, where's this here, boy? Yes. Now, pull it up now, we're almost done. So could you work out when x is -1? Okay, let's check my this in my head, please. When x is -1, you're getting 3 here. You're getting minus plus 2 here. -6. -6. So that's -12 plus 5 -7. Correct, Rebecca? That's correct, right? So in a differentiation, you will see questions like this, and you will see straight differentiation type questions, right? Rebecca, you okay with that, right? Okay. Right here, remember the first one, right? Right. Next application that you may not be too familiar with are the parametric equations. Okay. Right, so real quick, real easy, right? But it's something that you would not have done in form 5. So I just focusing on those areas, right? I'll finish yesterday. Right. Number, right. So let's take a look at the parametric, right? So if we have two functions, right? Let's say we have y in terms of f of t. So we have y in terms of t, and we have x in terms of t. Then dy dx is what? Any ideas? I have x in terms of t and I have y in terms of t. How would I get dy dx? How would I get dy dx? Right? I have y in terms of t. So if I differentiate this, what will I get? I'll get dy dt, correct? If I differentiate this here, what will I get? So how do I move from dy dt, dx dt to dy dx? Right? Kind of like chain rule, right? So I can say dy dx, sorry. I can say dy dt, right? Divided by dx dt. Correct? What will happen here? We already get what? Dy dt multiplied by dt dx. Kind of like when you raise a change. Remember that? Yes. Something like raise a change. Right? Same principle, right? So this is how you solve equations that are parametric. Parametric means you have x and y in some other variable. Are you okay with that? Okay with that? Tomorrow. Let's try easy one here. Let's try easy one. X is equal to cos theta. Y is equal to sin theta. Find dy dx in terms of theta. Try that fast. Try this one. Simplify as far as possible, right? X is cos theta. Y is that? See what you get. Finish? Finish? And finish it and read. Simplify as fast as possible, right? Simplify as fast as possible, right? Right, so you should have something like this. So you should have dx dt is equal to minus sin theta. Dy dt is equal to cos theta. Right? So it means that dy dx is equal to dy dt. Right? Dy dt divided by, you could also write it like this, divided by dx dt. Right? That's a rule here, right? Right? Sorry, I made a mistake. Supposed to repeat. Right? Dy dt is cos theta. Dx dt is sin theta. Right? So it's minus cos and sine, which is minus cot theta. Right? That's okay? That was our 4 marks, right? All right, that's our easy 4 marks. Next one. Last one here, combine parametric with a thing. So this is 2017. Right? These are the main things that focusing on in differentiation, right? I'm really going to spend a little more time on integration because those questions come a little bit harder. Okay? Differentiation doesn't be too bad except for 2019. Integration, I find this come a little bit hard. So we'll spend some time on integration, right? Right, during the crash course, I might extend the last day because I want to do some more module 3, right? Oh no, apply the problem. Something pure different. Huh? Yeah, about it. Because of the sample jam. Maybe one more is I had it as 5 days with them. Come on. Oh yeah, try this quick. Find dy dx and then find all the points on C such that dy dx is 0. Sorry. Oh. All right, let's go. Let's check this out, sum it up. Right, last thing I'm done, right? So divided t is what? Divided t is 3t squared minus 2t dx dt is equal to 5. So therefore dy dx is equal to 3t squared minus 2t over 5, right? You can leave it like that, or you can factor out the 5, right? Now when dy dx is 0, you can say that 3t squared minus 2t on 5 is 0. Cross multiply, you'll get 3t squared minus 2t is 0. You can factor out t. So when t is 0, you want to find the x and the y. And when t is 2/3, right? When t is 0, x is equal to 3, y is equal to 2. That's okay? That's your first stationary point, 3, 2. And then when t is 2/3, what? X is what? What's x? 19 on 3. What's y? Sorry? 50 on 27. Huh? And that's it. Those are your stationary values. That's all they ask for, right? All they ask for is all the points on C where dy dx is 0. So these 2 points is where dy dx is 0. All right? Right. I'm not going to spend much more time on differentiation, but focus is really integration for the next 2 classes. Yeah. All right? Just do my favor and ask somebody next week, like Tuesday or Monday, just remember to send the integration handout, right? With the notes. Right? In integration, we're going to integrate like normal, but one of the things that we had to focus on is differential equations. Right? We had to learn to solve differential equation, right? Yep, 6 marks just for that. All right, so that's it all, yeah.